The unknown, represented by x, can be found in both sides of the equations, but both of them are part of a grouping symbol. We need to apply necessary operations to solve for the value of the unknown. Let me copy here or rewrite our given. We have here 3 times the quantity x minus 7. This is equal to another grouping symbol, twice x minus 5. In order for us to solve for the value of the unknown, we are going to implement here first the distributive property, and after that we're going to return to the usual operations we did by removing terms and coefficients that can be found on both sides of the equation. So by distributing this 3 here and here, 3 times x is 3x, and 3 times negative 7, or 3 times 7 is 21, but since 7 is minus 7, you'll have here minus 21. That's for the left hand side alone. On the right hand side, when you distribute the coefficient of 2, you will have here 2x minus 2 times 5, which is 10. Now this method is very essential because you cannot remove any of the coefficients from the original equation without implementing the distributive property. And from here, we can now remove the terms. Let's start by using or picking the left hand side for the coefficient of x. In short, the negative 21 can be removed by adding 21 here. So that's negative 21 or minus 21 plus 21, that becomes 0. Doing the same thing on the other side, you will have this form. In short, what remains here is just a 3x and equal to 2x, and then negative 10 or minus 10 plus 21 is positive 11. Next is to remove this 2x here because we would like for this side to only contain constants. We're going to subtract 2x here and doing the same thing on the other side as well. So here, this side you will have 0. What happens to the other side is just 1x or simply x equal to the remaining term of 11. This is the value of the unknown. But to have an assurance, we are going to use here the checking, and we are going to use the original equation and the value of the unknown solved earlier to determine if that was really correct or not. Take note here that we are going to use the original equation, not the next version nor this version here. That is because we can only verify whether the value of the unknown earlier, x being 11, to be correct if this equation, the original one, will be satisfied. We could do that by substituting the value of the unknown here. So you have 11 minus 7. On the other side, you will have 2 times 11 minus 5. Now we use the same value of the unknown because we have the same variable or unknown x. Take note we are checking, so we are going to verify it like this. So you have here 3. Using PEMDAS, you start with the parenthesis. 11 minus 7 is 4. On the other side, still question mark, you have 2. 11 minus 5 is 6. Now even if this is already obvious, the goal here is to make sure that both sides of the equation will have the same value. Hence, 3 times 4 is 12, equal to 2 times 6, which is also 12. At this point, we have now verified that the value of the unknown being x equal to 11 is the value of the unknown in our given equation. Take note that we need to use here the distributive property first before other operations, and of course complete this step with checking. Join us to the next adventure involving the unknown.